Tackling climate change is everyone's responsibility, and utilities across the globe need to reduce the greenhouse gases they emit in delivering services. We have a huge opportunity to reduce emissions at wastewater treatment plants. Here, nitrous oxide, or laughing gas, is released as a byproduct in the process of biologically removing nitrogen from wastewater. With a global warming potential 310 times greater than carbon dioxide, nitrous oxide can represent more than 50% of a wastewater treatment plant's total greenhouse gas emissions, exceeding carbon dioxide and methane.
The amount of nitrous oxide emitted from a treatment plant depends on its design and operation. It is a bad news because the emissions from a treatment plant has to be quantified separately. It is a good news because it implies that we will have opportunities to reduce the emissions by optimizing the design and operation.
The challenge for the water industry is how to do this without compromising the plant function. A new and innovative method was developed to measure the spatial and diurnal variations in nitrous oxide emissions. Off-gas was continuously collected from floating gas hoods that were anchored along the activated sludge plant. The captured gas was piped to a centralised and online emissions monitoring unit. A programmable controller was then used to control the cyclic opening and closing of solenoid valves to direct the gas captured from the individual hoods to the gas analyzer at short intervals. This let us record nitrous oxide measurements from each location in real time. We applied this at 2 full-scale activated sludge plants at Bolivar, South Australia's largest wastewater treatment plant. This has provided extremely reliable spatial and diurnal emissions data. For the first time, we can accurately understand and quantify our actual nitrous oxide emissions. It's the first detailed data set ever reported for the step-fed design activated sludge plant, one of the most common treatment technologies around the world. Using this data, we developed one of the world's most advanced models that incorporates all nitrous oxide production pathways. This allows water utilities around the globe to predict emissions and causes at any location at any time. Also, we can now identify emission hotspots, enabling us to target and tailor optimization and control measures, whether it be operational or design improvements, cutting nitrous oxide emissions without compromising treatment performance.
We trialled one of these improvements. Optimization of aeration profiles showed a 30% reduction in measured emissions, in line with model prediction. It also improved plant performance, realising energy savings and improving total nitrogen removal.
This work has been scientifically validated, published in 4 high-impact publications.
And the project also serves as an excellent example showing how researchers and industry partners can work together to deliver benefits to the society.
This is significant. It puts the team at the forefront of the development of monitoring protocols and abatement strategies to address a major problem faced by water utilities globally.
This could inform policy and pave the way for water utilities around the world to reduce emissions. We are very excited to cut our emissions and help mitigate the impact of climate change as we get on with the job of delivering world-class water services for a better life in South Australia.
So this project features what we do with our wastewater recycling, and in particular focus on 2 key products. One is the biosolids, the other is the liquid, how we recycle, clean that water and make it fit for purpose. Biosolids have nutrients in plentiful supply, and the question is, are we preparing them? Are we using them properly? So I was hoping to take a product which is a very unique product, something that has great applications, but to improve it.
In compliance with state guidelines, biosolids are required to stockpile for 3 years to achieve highest stabilization grade. Our targeted research enabled us to demonstrate to EPA that 1 year is enough to meet the EPA requirements for the highest stabilization grade.
We have first of all saved significant capital on not having to extend our stockpile areas beyond what they are now, also for future growth actually. The other advantage or highlight advantage of this is that We reduced operational costs significantly.
Extended stockpiling period is costly because it will increase greenhouse emissions and it will reduce the fertilizer value of biosolids to the farmers.
The reason I like to use biosolids is two reasons. The one, for the environment, I think it's important that we start using recyclables where possible, and secondly, if you can grow grass, you can grow cattle. You can get fat cattle, and we get 2 and 3 cuts, which is probably unheard of on the peninsula. It's worked pretty well.
Previously, we were on a very conservative pathway in terms of looking at the safe reuse of water. And actually, the science has shown us actually that we're perhaps too conservative.
Our research suggested that log reduction value of 3 is sufficient to protect humans and animals from helminth risk. So our research also demonstrated that the lagoon detention time can be slashed down from 25 days to 18 days. Our research will potentially save millions of dollars. We don't have to build lagoons at a rate that is in line with population growth.
You know, we've been applying these guidelines for many, many years, and just by scientifically testing them and challenging them, it'll save not only immense amounts for Southeast Water on operations and capital, it will be for the entire water industry. If I talk about the lagoons, it'll be a global breakthrough.
In particular, this has got third world applications. Developing countries need this kind of science. This is a worldwide issue that we're tackling with some high quality research.
The University of Technology Sydney and Sydney Water have collaborated to design and build a world-first end-to-end robotic solution for preventing multiple pipe failures in the same pipeline. 6 years of collaborative research on pipe failure prediction provided insights to develop the new sensing and robotic tools to meet specific industry requirements for quick condition assessment in time-critical main break conditions. Sydney Water has over 21,000 kilometres of water mains, of which 4,500 are critical to the distribution of drinking water across the city. With over 175 critical pipe failures per year, costing around $30 million for reactive and $30 million for planned maintenance, the significant disruption and inconvenience to Sydney Water customers was the driving catalyst for the development of the R2T2 robot, to prevent multiple pipe failures in the same geographic region. Highlights and innovation. R2T2 enables Sydney Water and the Australian water industry to do things differently through the adoption of robotics automation technology spawned by the Fourth Industrial Revolution. It uses advances in artificial intelligence, data science, 3D printing and mechatronics to monitor underground assets in safer and more cost-effective way, to inspect confined pipes not suitable for human entry through human-robot collaboration. R2T2 intelligently and autonomously operates and navigates in various pipe diameters and pipe conditions. It builds accurate 3D thickness maps quickly in GPS-denied environments and can measure 100 metres of a pipeline in both directions in 2 hours and transmit the information in real time. The R2T2 robot is easy to use, generates quick results in time-critical conditions to enable rapid response by maintenance and repair crew. It is safe to use in water pipe break environments. R2T2 has created a number of significant benefits for Sydney Water. It allows preventative pipe replacement and repair of all affected sections of the pipeline while vehicle traffic is being controlled and water is shut off. The use of R2T2 reduces water loss from multiple main breaks. It allows improved services to customers by preventing future damage and disruptions. R2T2 is being operationalised for use in reactive and planned maintenance and will transform the way Sydney Water responds to critical pipe failure and asset maintenance protocols. R2T2 is also being used by other water-related projects and will be commercialised for other utilities to use. R2T2 will enable the Australian water industry to be global leaders in robotics for water-related smart asset management.
Biogas presents a key plank to the future sustainable energy mix. Many opportunities exist in Australia to generate this resource through the anaerobic treatment of industrial effluent. EI's research has developed a more robust, cost-effective and reliable solution for biogas capture.
Quite often you have a number of anaerobic reactors. It may be completely covered, a monolithic structure, and if something goes inside, you don't have any access. Ongoing cost of maintenance of that is quite high. And if there is any local damage to one point, all the gas will be going out. It can cause a lot of damage, and the whole downstream power generation system will have to be switched off.
We're investigating the feasibility of installing a gas capture system for one of our clients who has a large vertical anaerobic reactor system. And we found it was actually too cost prohibitive to retrofit to such a large existing system. And that's what inspired us to look at new options and research new methods for the capture of biogas.
This is a technology suitable for capturing biogas from anaerobic reactors and lagoons. So we had a series of rectangular tanks where they would flow, but any wind event or any event, it can actually stabilize by itself. If one of the covers got damaged, remaining ones will function, so you still get power supply there. And other issues like rainwater management, water level fluctuation, all the other issues with that you currently face with the existing technologies, we can easily overcome.
One of the most innovative aspects of the SSBC is its integration with Internet of the Things and real-time data. The SSBC can be controlled to sync in the event of an extreme weather event.
And we looked at a number of options, and believe me, a lot of structural, mechanical, hydrostatic, all sorts of calculations we have done to finalize the design, which material you need to use, how much should be the thickness and how much should be the internal pressure. Then we worked on the gas pressure inside and the roof dimensions, which is the optimum one for different materials. In the central axis, how much it should go below the water level, etc. One of the fundamental things is obviously the cost. Second thing is ease of fabrication and the transportation, craneage, and how you can implement the instrumentation and control system. Can we go it further from here? Yes, it doesn't have to capture biogas, but it can prevent evaporation because it's still modular, easily replaceable, and it can also be used for controlling emission of odorous gases. The advantage of this is it can be retrofitted to existing reactors and lagoons. The cost is much lower. It's very resilient to withstand extreme weather events. Any local damages can be easily repaired and without shutting down your power generation downstream. Thank you, everyone.
Most people don't realise their pee has a huge amount of potential. It's full of nutrients like nitrogen and phosphorus. To harness the power of pee, Queensland Urban Utilities teamed up with the University of Queensland to launch the UGOLD project, a world-first technology designed to reduce wastewater treatment costs by removing and recovering the nitrogen, phosphorus and micronutrients right at the source, the toilet.
Currently, up to half of our energy use goes towards removing nutrients from wastewater, mainly nitrogen and phosphorus. While urine makes up less than 1% of the volume of wastewater that arrives at our treatment plants, it contains 80% of the nitrogen and 50% of the phosphorus in sewage. The goal of the UGOLD project was to demonstrate that urine separation and treatment at the source can be integrated with urban wastewater management schemes. Here at the Luggage Point Sewage Treatment Plant, we've been encouraging our employees to donate their number ones in these 2 purpose-built waterless urinals. The urine flows through a series of battery-like systems with the energy harnessed from the urine itself. The technology is entirely chemical-free and only requires minimal electricity. The result? A concentrated, nutrient-rich product for reuse.
Removing nutrients at the source has two main benefits. It reduces operational and maintenance costs, and it helps avoid the need for plant upgrades. It also means we draw less from our valuable drinking water supply by using waterless toilets. Another key aspect of UGOLD is that its product is a fertilizer, which will reduce our dependency on non-sustainable fertilizers. We're taking the waste out of wastewater and kicking goals in doing so. We've shown the practical feasibility of separating and handling urine at the source. We've achieved a volume reduction of 90% while recovering 50% of key nutrients at rates well above those achieved in sewage treatment plants and at a fraction of the energy requirements. We're producing a steady stream of liquid fertilizer, which is free of pathogens and organic micropollutants, reusable in urban greenery and landscaping.
As the population of modern cities continues to grow, Queensland Urban Utilities is looking at innovative ways to turn waste into valuable resources and make our operations more efficient. The UGOLD trial has provided us with invaluable data around potentially upscaling the technology for more sustainable and resilient wastewater treatment in the future.